Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the June 2024 replacement paper for Pure Mathematics P1. This question here, we have a curve which has equation y equals 2 over x plus 3x minus 4, where x cannot be 0. The straight line has equation y equals kx plus 2, where k is a constant. Show that L meets C when this is true. K minus 3x squared plus 6x minus 2 is equal to 0. So we know that two functions intersect, they meet when you find the points of intersection, which is done by substituting one of the equations into the other, solving the two equations simultaneously. So how do we solve the equations simultaneously? Okay, I don't like the word or the phrase equate them to each other, because sometimes that doesn't quite work. In this case, it does work, but in some cases it doesn't work. It doesn't really make that much sense, and it causes problems. It causes people to have issues with rearranging things when they don't need to. Rather, you should think in terms of substituting one of the equations into the other. So what I'm going to do here is I'm going to take what y equals, which is kx minus 2, and I'm going to substitute that instead of this y, because y equals kx plus 2, I can replace the y here with kx plus 2. That's the way you should think about these things. So I'm going to substitute this equation into the other equation. That's a bit bad. 1 second, let me sort my pen out. All right, so that goes into there. So you're going to have kx plus 2 is equal to 2 over x plus 3x minus 4. Okay, now these are the type of questions where the fairy story style of understanding maths starts to fall apart. So what we have to do here is we want to get rid of the fraction so that we have an equation without any fractions. And in order to get rid of the fraction, we have to look at the denominators of both sides of the equation, and we have to multiply, find what the LCM is. Here it's just x. So I have to multiply both sides of the equation by x. Okay, so I have to multiply this side by x and this side also by x. You don't say, oh, we have to move the x to the other side, and then suddenly the x sprouts wings and flies to the other side. And the mistake that people make, they'll say kx squared plus 2 plus 2x equals, and they'll just put 2 plus 3x minus 4. They just move the x to the other side. Well, it doesn't just move. How do we get rid of it? It's dividing. We multiply both sides by x, which means we have to multiply both sides of the equation by x. And when we multiply this side by x, we multiply every term by x. So please get out of this fairy tale style of learning about mathematics, about things moving to the other side. Think about what's actually happening mathematically. Otherwise, in questions like this is where it shows. That's where many people make silly mistakes like that. So that's why from the beginning you shouldn't learn your maths in such a way. Okay, so x times kx is kx squared. X times 2 is 2x. X times 2 over x is 2. Objective, that was the objective, to get rid of the denominator. But then x must be multiplied by the other terms. So you're going to have plus 3x squared and minus 4x. Now what we want to do is we want to make everything on one side of the equation. Now they've got it as k minus 3x squared. So it makes sense if we bring everything to this side. So everything has to, this side has to say equals 0. So we have to get rid of all of these things from this side. Okay, so don't say move it to the other side. Say, okay, get rid of it from this side. Rather than thinking of moving things, think of getting rid of. So we have to eliminate the 3x squared from this side. We subtract it from both sides of the equation. So you can't just, what you do to one side, you do to the other. So you subtract 3x squared from this side, you must subtract it from this side as well. You want to get rid of the 4x, it's a negative 4x. You want to add it to both sides. You're going to have 2x plus 4x, which is 6x plus 6x, and here you've got this 2. You want to get rid of the 2. You've got to subtract 2 from both sides. You end up with this, and you can see that we're almost there. the only thing left to do here is to take the k out as a factor from those two x squared terms. So what we can do here is we can write this as k times, in brackets, x squared minus 3x squared. In fact, what we did is the opposite. What they want us, yeah, that's right. No, actually they want us to do, sorry, my bad, x squared is what's common. So we're going to take out x squared as common, and we're going to have k minus 3. That's kx squared minus 3x squared plus 6x minus 2 equals 0. So then we can write it in the form they want. It's k minus 3 times x squared plus 6x minus 2 equals 0. Okay, so there's part A done. Now part B says, hence find the values of k for which L is a tangent to C. So you have these two equations. One is a curve. How it looks, okay, you know, that's debatable. We don't really have to know. But just in general, when you have a curve and you have a straight line like this is, okay, you have a curve and a straight line. Now a curve and a straight line can either not meet at all, in which case there will be no solution, or they can meet in two places or more sometimes if it's like a cubic, something like that. Or the other alternative is that the curve and the line, okay, the line is such that it's a tangent to the curve, in which case it will touch it or meet at one place. It won't intersect through it, it will just touch at one place. Okay, and that's the case that we have to look at. The value of k for which L is a tangent to C. Right, so when we want to find that, we have to have the equation. We have to basically try to find the equation which tells us about where they intersect, and that's exactly what we've just found. So this is the equation that tells us about how and where they intersect. All right. Now this equation, okay, the number of solutions of this equation will tell us about what type of line, how the line and the curve are related. So if the line is such that it doesn't meet the curve, then this equation will have no solution. If the line cuts the curve in more than one place, in two places, then this line and this equation will have two separate different solutions. But if the line is a tangent to the curve, then there will be one, you can say repeated root, one solution. Okay, and that's the case that we're looking for. And what determines how many solutions a quadratic equation has? Well, if you think about the quadratic formula, you have minus b plus or minus the square root of b squared minus 4ac all over 2a. This part of the quadratic formula determines exactly how many solutions they're going to be. This is called the discriminant. Okay, and if the discriminant b squared minus 4ac is greater than 0, that means there will be two solutions. That's the case like this. All right, there will be two distinct solutions. Two distinct solutions. And if b squared minus 4ac is less than 0, when this is going to become negative, and you have the square root of a negative number, which means there will be no solution. So b squared minus 4ac, when it's less than 0, there's no real solutions. Okay, that's that second case. All right. Now, for the first case, why are there two solutions? Because you have minus b plus or minus something real. There'll be some number there. So you'll have minus b plus that number over 2a, one solution, and minus b minus that number over 2a, a completely separate solution. But when it's like this will be negative. When this is negative, then you have minus b plus or minus the square root of a negative number, which is undefined. There'll be no real solution. And the case that we're looking for is when it's a tangent to the curve. In that case, we're going to have what's called a repeated root. B squared minus 4ac is equal to 0. You have one, okay, repeated solution. You can say repeated, one real repeated solution. What that means is you're going to have minus b plus or minus 0 over 2a. So it's just be minus b over 2a, just one answer. Okay, and it's called a repeated root. Okay, as we will see later on when you're doing sketching of graphs. because it turns on the x-axis. It's like the two answers twice. Okay, so this is our case that we are looking for now. Okay, that is a tangent to the curve, so there will be one solution. That's the case we're looking for. So we have our quadratic formula, ax squared plus bx plus c equals 0, and our discriminant is b squared minus 4ac. So a is equal to, in this case, k minus 3, the coefficient of x squared. B is equal to 6, the coefficient of x, and c is equal to negative 2, the constant. So our discriminant is going to be 6 squared minus 4 times k minus 3 times minus 2, and that has to equal 0. So you have 36, that's going to be plus 8 times k minus 3 equals 0. I just want to make sure I don't mess up with the sign. So minus 4 times minus 2 is plus 8. So you're going to have 36 plus 8k minus 24 is equal to 0. So 8k, you're going to have 36 minus 24, which is going to be plus 12 equals 0. So k is equal to minus 12 over 8. So k is equal to 3 over 2. Negative 3 over 2. Why? Because 12 over 8 is 3 goes into 12 4 times. 4 goes into 12 3 times, and 4 goes into 8 2 times. So k equals negative 3 over 2. And that is the solution to this question. Question number 4. Is there another part to 4? No, there's no other part to 4. Okay, so there we have the answer. And that concludes this question. Question number 4 from the June 2024 replacement paper for the for the Edexcel International A Level Pure Mathematics P1 paper. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic of, this is to do with quadratics. Okay, you can find that in the playlist at the bottom right. You can subscribe to my channel by clicking on this link, and the video here will show you how to use my channel to find what you might be looking for. Thank you for watching, and see you soon.